Discovery, go at throttle up. Go and throttle up. Discovery, go and throttle up. Discovery, go and throttle up. Discovery, go and throttle up.
Okay. Wait, you heard me double. Now you're not. All right. How's everybody doing? Welcome to the Space and Rocket Review. You two girls, tell your friends. Oh, wait, no. Space and Gridfin Review. You in the hat. You two girls, tell your friends. All right. Let me just reconfigure the audio here. If we want to pipe the guitar through to the stream, I have to change some things around here. Give me 1 second. Okay, there we go. Nice. It sounds like Eric Johnson. Play clips of Dover. That's the wrong Eric Johnson. But all right, that's fine. That's fine. The Gridfins go in the square hole? No, but they got a lot of square holes. How's everybody doing? Everybody doing well? Everybody doing well? I hope so. Pretty good? Pretty good? All right, cool. Cool. All right. So, space news. Flaming good now that you're on. Oh, thank you. How are you? I'm good, Peter. Yeah. Is this the Peter Gridfin review? Here, Gridfin. Ah, crap. All right. Okay, so. All right, let's get everything going. I don't care about what's new with the browser. Thank you very much. All right, next space flight. So 17-4 is now at 12:26 a.m. Eastern. Oh boy. Oh boy. Baron, you're in White Sands. I spent all day outside, so you have an idea how I feel. It's 100 outside, by the way. Yeah? So? Okay. All right. So, yeah, me just being my hot mess of a self lately, I don't have much in the way of like news. So you guys kind of tell me what you want to talk about. I have a feeling it probably has something to do with this. 113 today in Phoenix. Nice. Nice. Hey, Dick, what's going on? I love the smell of hypergolic fuel in the morning. Yeah, you probably shouldn't. Can you smell anymore, or? SpaceX tweets in the Spin Prime this morning. All good, Creeper. All good, buddy. All right. So, we'll start off with this. The Gridfin and its jig are making me feel things, chat. Holy shnikes. So, SpaceX posted this. Check this out. They have some really crazy pictures of the Gridfin and the assembly jig for said Gridfin for Super Heavy, for one of 3 of the Block 3 Super Heavies. I'm going to 3 of the Block 3 Super Heavies grid fins. Holy balls. That is crazy. The world's biggest waffles, tasty waffles. Yes. Saw that, Helsinki. It's crazy, right? It's pretty sus. Dude, look at some. Oh my goodness. Billet steel. Dude, that is crazy. Look at the welds in there, man. Oh my goodness. Dude, the outside steel here on these fins are... Oh, you shimmed it with a putty knife. That's good. Sure, that's fine. Look at all this. This is all billet steel. It's not titanium. That's just straight steel, dude. With integrated catch pins. The assembly jig, dude. Look at this tooling. Oh my goodness. That's a lot of welding. That's about the amount of welding we have left to do on the Coronet. Plus this right here as well. Putty knife is just a high quality shim. Well, clearly your grid fin is a little bent. There ain't no putty knife over there. Wow. Don't fall over and check. Yeah, I was gonna say, Tessa, that would hurt a lot. But dude, even the inner parts of the fin here, that's half-inch steel. It's got to be half-inch, and at the very least, half-inch steel. How is this? Dude, look at the outside wall. That's an inch thick. Dude, this thing probably weighs as much as the Coronet. One of them. This is not CNC machine. The outside edges are. These are manufactured parts. That's CNC. So this is billet. These pieces right here are billet. They started with a chunk of steel and they made this piece right here. And then same with these pieces. See the pieces that have these recessed marks and then the pieces that have the stripes on them. That's where an end mill went back and forth in a CNC machine. And that's what the assembly jig is for. That's what all this stuff is. All this stuff with all the bolts. Oh, wow. Dude. Flanged hex bolts. Flanged grade 8 hex bolts. Man, SpaceX.
Discovery, go at throttle up.
That's expensive hardware, dude. Man. And how about the freaking bearing in there? Okay, cool. So these pieces right here, the actual parts of the fins, that is plasma cut. That was on a CNC cutting table. And then they placed them all together, and that's what these pieces are here for. They're here to place everything so you can get everything nice and set up straight. That's what I should have done with the car, but it's fine. It's fine. And then it's welded 3 times, I think. One, 2, and then probably one down at the bottom. Yeah, see, 1, 2, and 3. Dude, that probably took some time to make that. That probably took some time to make that thing. Oh. Wow. Dude. The master sales representative responsible for our account told me that SpaceX is their biggest client in the aerospace sector. Yeah, I believe that. Holy heck, look at that seam, dude. Whoa. Dude, even the tooling jig is just Oh, there's the putty knife. Oh, here comes the putty knife. See, dude, there's still a seam right there. I don't think they finished. I don't think this is finished. How big is it? John, look at that. There's the dude's standing there. That's huge. That thing is huge. Okay. You really think it's a plasma cutter job? I think that these pieces were CNC plasma cut and then welded into position, yes. I mean, there's no tooling marks on them, dude. There's no tooling marks on any of this. This is all CNC cut stuff. That's the stuff that's billet. The billet is the strongest. The strongest stuff is the foundation of the Gridfin, but this stuff is not. Yeah, that's all CNC cut, dude. There's no machining marks on this thing. It could be a water jet. It could be a plasma cutter. It could be, I mean, could be anything. I mean, any type of CNC cutting. I mean, it's definitely CNC. It's definitely cut. It's definitely computer controlled cutting. Nobody did that by hand. It's too perfect. They used a Dremel. Yeah. I'm sorry. I'm kind of swooning over this. This is some machinery porn right here. Wow. Why would they do it by hand? So ineffective. What do you mean, Baranok? Like weld it by hand? Uh, don't get addicted. Yeah. Yeah. That ship sailed. This is a Gridfin. Yeah, 1 of 3 for a super heavy. These billet parts. I mean, this is all steel. It's not aluminum because you can't weld it to steel. You can't, well, I mean, I'm sure you could find a way to get them to adhere, but this is definitely all steel. So how many flights do you think a steel Gridfin will be able to take? I mean, it's going to a blade after a while, especially around the tip right here. Selfish. That's the believe it or not, the tips of the Gridfins right like here, and here. Those are the that's going to be the hottest point right there. And dude, I guarantee you that these angles are there for the resulting plasma layer, plasma boundary that comes from this. It shoots it off to the side, and I'll bet you it shoots out at that angle during its hottest point. It looks like precision ground steel. The face looks like it was hit with a grinder. A big one, dude. Whatever. Yeah, the big CNC. Like, see the wavy marks? That Gridfin's probably cheaper than Falcon 9's cast titanium ones. Yeah, possibly. Unbelievable. So SpaceX also posted other pictures here. Here, take a look. And they're just... Oh. Wow. Are the horseshoe-shaped objects along the perimeter of the fin part of the construction jig? The painted stuff, the stuff that's painted white, is the assembly jig. Yeah, and anytime you see these circles right here, that's part of the assembly jig. These pieces right here. Here, I'll use the other one. So these pieces along the outside, no, the silver bits. So the white pieces along the outside with the golden colored bolts, those are part of the assembly jig. The floor, this polished part right here, that's part of the assembly jig. The circle right here is part of the jig. That's a big magnet if I'm looking at that right. And then these little guys right here, see those? Those are there to get the angles correctly. And yeah, I don't know. Let me look at this up close. I'll be able to tell you. Yeah, see, Some of these are just one long piece, and some of them are just one. Some of them are like multiple U's, I guess. And some of them are just singles. You can see because of how that bracket is how these were welded together at the top. See how it kind of the plus sign favors this direction. So that means that like from here to there is probably one piece, and then that's one piece that connects that there, and there, and that's probably another piece right there. But yeah, that's anything from here, like see this piece with the angle marks right there. Anywhere from here in, that's Gridfin, except for the floor and these little square bits. Anything outside of this on either side, that's part of the assembly jig. And see, there's no brackets here and here. That shows that they use one jig for multiple phases of Gridfin construction. So that tells me that they're making this part first. They're welding all of this sucker together, the strongest part, right? They weld that first, and then they remove these pieces when this is nice and straight, and they start adding the sidewalls, and then they probably add this piece and then make the rest of the fin. Get that thing I sent you? No, I didn't. No, I haven't, Tessa. My guess is that they're half cut. Yep. Okay, I was asking about the circular things you said are magnets. They just look like horseshoes. They're partially covered by the fin. Yeah. They're full circles, dude. Yeah. Those. Sorry, I can see the way this thing is put together. Those are full circles. They're magnets. I'll bet you that's there to help hold the piece in place. So if you butt this plate up against this piece right here, right? And then you lay it down on the magnets, right? There's probably another one over there, right? It'll get perfectly straight. You level it, and then you weld it into position. It's funny because the Gridfin is not true. It's not perfectly true. It's close, but it's not. See? You're about 1/8 of an inch off right there. Interesting thing from my relatively limited metalworking experience. If you look at the other side, the exact opposite, there's a putty knife stuck in over there, and there's a putty knife stuck in on the opposite side over here. It's not completely square. She ain't square. Is there any putty knives anywhere? No, there isn't. No, it's not square. Why did I... Oh, no. I thought I was making a joke. It's definitely... Dude, it's out of... It's not by much. It's 1/8 of an inch. Who cares? That's not going to make that big of a difference. As long as this part is nice and true, it doesn't really matter. But this was MIG welded. These guys right here, that's all MIG welding. This right here, I'm not 100% sure. That could have been stick welded. It's possible. It's in spec. It's in spec, Zizep. I'm sure it'll be fine, but it's not square. It's not perfectly square. Like that Gridfin is kind of bent. It's kind of bent one way, because if it was square, there wouldn't be a shim in there. See that bracket right there? There's a putty knife in the damn bracket. Some of these brackets have a slotted piece to adjust, right? If anything is out of whack. But the bolt's at the end of the slot, and there's still room. Uh-oh. And then, dude, it's funny because if you look at, the Gridfin in the next picture, shows it on the exact opposite side. Oh, it's out by the same distance. Oh, my goodness. It's not square. I can't unsee it. Why did I even point this out? I played myself so hard. Dude, there's even a mark. Somebody wrote on it with an arrow pointing at it. I think that's an arrow. I don't know. It doesn't matter. It's okay if it's a little out, guys. It looks pretty damn square to me. The tolerance is probably okay. I'm pretty sure this will Gridfin just fine. But also, mother trucker! Oh, dude, You know, that makes me feel better because, you know, with the car, you know, you chase that extra quarter inch and you chase that extra, not quarter inch, too much, way too much for that. Chase that extra eighth or 16th of an inch just to get it perfect. And okay, that happens. Of course it's not square. It's an octagon. Oh, yeah, I know. Of course. How stupid of me. In the grand scheme of things, yeah, it's not going to make a difference. I'm just making a joke, but also it's not perfect. It's close, but it's not perfect. Tight tolerances are expensive to attain and should be applied only where you need it. Bingo. So anyway, yeah, those are the grid fins that are going to go on this thing up there. Oh my goodness. Yeah, the fixturing is quite nice, Coltec, yeah. It might be by requirement because it's, yeah, maybe it's one on one of the sides. Yeah. Oh. In-tank grid fins. Yeah, I don't, all right. Dude, look at the quick disconnect for super heavy. What is that? They made the quick disconnect look like a... I'm failing to come up with a name. I don't know. It looks like a Trimaxian drone ship or something. Look at the umbilical arrangement on that thing. That's cool, man. Wow. Yeah, it looks like home plate. There you go. Baseball season. Yeah, it'll be difficult to get right. I mean, it's on a raised pyramidal structure. That shouldn't be too hard to locate at all. The triangle, also the thing went to the PO box. Oh, okay. Are those pipes exposed? It seems like the autogenous pressurization lines are exposed, yes. Oh my goodness. Why are they going with 3 fins instead of 4? You only need 3 fins to control yaw, pitch, and roll, dude. That's the booster carrier umbilical thick, yeah. At least I'm pretty sure it is. I don't know what else that would be. Because there's another one right there, and those seem to match the clock positions on the OLM. It looks like the Millennium Falcon. Yeah. Yeah, there's also weight savings bonuses here, but you only need 3 fins to control yaw, pitch, and roll, guys. That one can control yaw. These two can control pitch and roll by modulating the angles. So, like, you want to roll, turn 1. You want to roll right, turn 1. You want to roll left, turn the other. You want to pitch, turn both of them. So they could do this, right? They could do this, or they could do this, or doors could open up like this, you know. And then that one is controlling the yaw. Now, once again, these little strake or chines or whatever you want to call them, these elements that are on the sides of the booster, those are going to give you a little bit of body lift because air is going to get compressed underneath it. This thing's going to fly, dudes. Is she going to fly? I've seen it. It flies. It doesn't come in like straight down. Super heavy comes in like sideways at like almost a 45-degree angle. The 4th would probably interfere with the tower as well. Yeah, Cyborg, that's actually another important thing to understand. The catch pins in this design are underneath the 2 grid fins. Yeah, catch pin is right there and right there. So the way this thing will be caught, this grid fin will be opposite the tower. The tower would be right here. But it doesn't have jet engines and landing gear. No, you ain't wrong. I would like to see them at 120 degrees. It just doesn't look right. I know what you mean, dude. I know what you mean. Wait. Yeah, see? The thermal protection system on Starship is facing out away from the tower. The tower would be close to... Huh. The chine position, guys. Look. So if we're looking at super heavy from like the back, right? So like all your engines are, you know, down here, E, right? Say all your engines are here. I'll just put the 3 in the center because, and then we'll just write 33 ang, right? If I'm looking at that right, it looks like the chine position is like this. Like that. See what I'm talking about? And in this add block, if I'm looking at this design, right, these top ones right there, so the tower would be right here in this design. And then you'd have grid fins. You know, you have 1, 2, right? Look at that. That's weird. I think it's to keep them away from the sticks. It looks like the wide, wait a minute, hold on. Yeah, the wide ones are on the side of the booster quick disconnect. So you have your disconnect points. Your QD for the 2 umbilicals is right there and right there. Interesting. Huh. Well, okay, so fellas, why would they do this? Why would you clock the chines like that? When I say clock, I mean their position relative, like on a clock, if you went all the way around. They're clocked at like 11 p.m. and 1 p.m., right? Why would you do this? Well, this is your yaw control, and right here, when super heavy, here, let me figure out a way to draw this. So, right, when super heavy's coming in, so 1 grid fin will be right here. Right, another one would be over here. And then the last one would be over here, like that. Right? When it's coming in like this, your chines on the bottom are going to be close to each other. I mean, the chines are exaggerated in this, right? And then comparatively to these ones, like on the top, these ones are going to be close. And them being close to each other, guys, is going to create a ton of lift. It's going to create a ton of body lift. It's going to create a ton of compression. Air is going to get trapped on the short side of the fins right here when it's coming in, right? That's going to generate body lift. This thing will fly. That's what I'm trying to tell you. It's going to fly like an airplane. Not like parallel to the ground, but those chines are going to generate a ton of lift up there. Right, so you'd have 1 chine here, you'd have the other one there, and then these ones are like super close. Like that. How much heat will be generated in those areas? Not a lot. You got it upside down. I don't think I do, actually. No, I'm pretty sure I don't. Yeah, no, I don't. No, that's right. The short grid fins, the 2 grid fins that are, or the 2 chines that are close to each other are on the side with no grid fin. The wide chines are on the side with the grid fin, like this. when this thing is coming in, it's going to generate a ton of lift right there because it'll work like a lifting body, basically. Yeah. I'm guessing it'll re-enter with the yaw fin downward to avoid aerodynamic blanking effects. I don't think that blanking is going to happen with this thing at these speeds, Nader. No, I'm pretty sure it's good. You got to remember, it's flying like here. This is from the side. The booster is going to come in like this. You're never not going to get laminar flow over that grid fin. Now, another thing, Nader, to take into account is that you do not need a lot of deflection on that to yaw this thing. You're going to get a lot of control moment from that. So what fin will do what control? This is yaw, and this is pitch and roll. It's an airplane, guys. It's an airplane. And then your chopsticks will be out here like that. And then your pins, the catch pins are going to be here, and then same place on the other side. They're below the pitch and roll grid fins. The booster has to come in the other way because the booster quick disconnect is on the other side of the OLM away from the tower. I know. You guys are not doing too well with your spatial orientation, huh? Maybe you guys need a week off. Jeez. Does that mean we'll have to do a roll program upon landing? Well. Oh. Hey guys, excuse me. I might need another week off. I'm going to go lay in the pool for a little while. I'll see you. No, actually, you're right. You're right. Nader, you're correct, dude. You're correct. I'm wrong. You're going to have to re-enter with the yaw fin downward. So yes, you're right. I'm incorrect. You got me on that one. No, that's smart. That's right. Yeah, you guys are right. It's going to have to re-enter with yaw grid fin down. So this is a misleading drawing. Hold on. Let me fix it. I'll fix it. Shut up. I need another week off. I want to go sleep. I'll go sleep in the pool or next to the pool. So in this design with what SpaceX is doing, that sucker's downwards like that. It's underneath. That like that. Because yeah, that's going to make it so it has to, yeah, because the tower, yeah. Okay, we got it. Wait, but that doesn't make sense now. If it's yaw, if it's downward yaw, that means the close chines are on this side. Like that, right? And that means the far chines would be over here. Oh, I see what they're doing, these sneaky bastards. Watch this. So, let me just erase some of this, erase some of that, right? So we know that these, from looking at here, hold up. I'm seeing it. I'm figuring it out. I'll get it. Just bear with me. Shut up. I mean, no, don't leave. All right, they're not coming back. Okay, so look. These are RGV aerial pictures. Look, the two umbilicals, they're not 90 degrees off of each other. They're more like 60 degrees off of each other, right? See that? It's not 45. 45 would be right here. So, okay, here's what they're doing. That means that your disconnects are right here and right there, right? Which means your chines go like this. And see right here, you're going to generate amazing amounts of lift underneath this thing. And Nader, you were right. If that thing's on the underside and the chines are making tons of body lift, you are going to have insane yaw control moment here, meaning that grid fin, if it turns, it's going to steer the whole damn booster to one side. Like that thing is the key to this design. It's basically, the chines are basically channeling, they're compressing air and shooting it back towards that grid fin. That's smart, man. That's real smart. This is what I mean by keeping the chines away from the chopsticks. Yeah. Yeah, I got you. Yeah, I understand. I drew it right here. You're talking. Yeah, hold on. I gotta change the color. We'll change the color. We'll change the thickness. So the chopsticks are gonna be like right there, right? They're gonna be in like that. And then the catch pins we know are right there and right there. They move the chines in. And the chines on that side. Dude, this is really smart. That's really smart, dude. Wow. This is really, guys, that's a really succinct design. That's really, really good. Real good. Like, It's like, no. I want the Villa Scalapini. I want the short penny Alfredo. A bottle of fettuccine di 1981. The only thing we serve is tongue. You boys like tongue? That's why SpaceX people get paid the big bucks. Yep. Yep. 40 chess engineering. You know what? Pretty good, man. Did you see any meteors? No. No, I didn't. I got brains through copious consumption of only high-quality Crayola brand crayons. I was about to ask, what's your dietary regime, man? I'm in. No, you were right, dude. Yeah. Yeah. I had it upside down after calling Chad bad at spatial orientation. I was like, you guys are wrong. Oh, I know you're no, maybe I'm wrong. Sorry, man. Can I take another week off? Like, no. All right, cool. Blue Origin tweet. Okay. How screwed is this design if the grid fins lock up? I don't think they will, Neo. The grid fins aren't going to lock. They're using a Tesla. If I'm understanding this right, they have a Model X motor attached to this thing. So the only time SpaceX has had grid fins lock up in the past is when they were using a hydraulic control system. SpaceX actually used RP1 for their hydraulic fluid, and then at one point. But they switched to a closed-loop hydraulic system. But Super Heavy's grid fins are not hydraulic at all. Why? It's too heavy. You already have electrical systems on the vehicle. You already have high-powered batteries. Use those. Oh no. The phones were off. What is this? What is this? What? Square hole, tip the dollar. I asked the waiter, will my pizza be long? He said, no, it'll be round. Wait a minute, Creeper. Are you telling me they're gonna catch on the fins? Wait a minute. That's the catch point? Right there? Damn, dude, this thing is gonna be righteous. Holy crap. I was wondering why they had so much beef in here. That's a thick plate of freaking steel, dude. It's, damn, boy, she thick, boy! Like, I was wondering why you had, like, I mean, dude, it's gotta be 10 centimeter thick. It's freaking huge. That, like I said, this Gridfin probably weighs more than my car. Do you think if they rotated, they could stabilize for off-angle catches? Well, well, Graham, I think they took that into account. Look at the catching surface. If that's the catching surface, it's convex. So yeah, they took into account grid fin rotation in the catch, which just fudge. Dude, this is sick. This thing's awesome. Like, wow, what a treat. Then it won't wobble. It won't wobble. You're right. Oh my goodness. Oh my dude, this thing is sick. Wow. Why do you think they made these design changes? Going from 4 smaller, top 3 bigger fins can't be that much cheaper and lighter. Uh, Drummer, I mean, first of all, with Delta V, okay, so first of all, you're dealing with a crappy mass fraction with Starship to begin with. The reason why you're dealing with a crappy mass fraction is because they made it out of steel, first and foremost. Second of all, dude, that grid fin weighs as much as that grid fin probably weighs as much as my 97 F250. It probably weighs as much as the white trunk. I would say a very conservative estimate would be, yeah, about, I don't know. I don't know. Hold on. So my truck, short bed long box config F250 weighs 4,100 pounds. Basically about 1900 kilos. Yeah, I'll bet you it weighs more than that. Yeah, I bet you it weighs more than that. Dude, look at the beef, man. I bet you that thing's 2 to 3 tons easily. That weighs more than my damn truck. So, I mean, drummer, the other thing is SpaceX, just like a very, very, very awesome British race car engineer, Colin Chapman. Uh, they use his moniker as well. Simplify and add lightness. You have 3 axes of control. 3 grid fins will do you just fine, right? The grid fit. See, now I know what people are going to say. Won't this make it kind of asymmetrically aerodynamic? No, no. For grid fins to be effective control surfaces, the curved side right here has to be going into the wind. They are uh, about as aerodynamically useful as a screen door if the laminar flow is coming from the opposite side, coming from this side going that way. Like, so on the way up, they do nothing. They make a little bit of drag and that's about it. You could see a crane or shackle to determine the weight. I mean, with that strap right there in that block, that thing is pretty friggin' heavy. Screen door on a submarine? No, screen door on a battleship. So, simplify and add lightness. SpaceX is already dealing with some pretty hard mass fraction problems here because they chose steel. But the plus side is that making it out of stainless and regular steel makes it a lot easier to manufacture than an aluminum rocket. They're also lifting its welding jig. Yeah, I'll bet you the jig weighs more than the fin. That jig is some thick boy steel. I mean, dude, that thing is heavy. That thing is really heavy. It's also not square, damn it. SpaceX, what are you doing? So let me go and read the tweet. Sorry, I like to look at the pictures first. First grid fin for the next generation super heavy booster. The redesigned grid fins are 50% larger and higher strength, moving from 4 fins to 3 for vehicle control while enabling the booster to descend at higher angles of attack. Dude. It didn't use the square hole, man. Yep. They'll also be used for vehicle lift and catch, made possible by a new catch point addition and a lower positioning on the booster to align with the tower catch arms. My brain do good. Moving lower reduces the heat they receive from Starship's engines at hot staging and places the fin shaft actuator and fixed structure inside of the booster's fuel tank. How the hell? How the heck? No, Milge, that piece right there, that's the lift point. Oh. Are they still titanium? No, Roy, these are steel. I'm not sure what type of steel, dude, but my knowledge ends there. But I know that's steel. It only saved the weight of the Gridfin, but also the motor, battery, wires, and so on. That's right, Livin. Yep. Do you think that part of the reason why the grid fins are 90 degrees apart is to have an empty side for barge transport? Oh, Matt, you might be onto something, dude. Matt, that's Mafia Matt, that's good. That's good. I think you are right. Yes, absolutely. Yeah. Yeah. Horizontal transport. Yeah, that's good. Dude. SpaceX is cooking. Am I using that right? Am I using that term right? SpaceX is cooking. They are cooking. This is excellent, man. This is like top shelf engineering, dude. they cooking. SpaceX is the GOAT, dude. That's sick. Like, pardon my French. That's fucking cool, dude. Oh my goodness. Chrome Kiwi has a good render of it. Oh, dude. Actually, you guys, I don't know if you guys know, Chrome Kiwi does renders on X. Chrome Wiki, no, Kiwi. So Chrome does renders on X, and he actually gave us like official permission to show this stuff, dude. Yeah, this is it, dude. Look. So look. Mafia Matt asked, okay, so if this thing has 4 grid fins, right? If you tried to tip it over, you'd have to turn the grid fins at like 45 degrees to the ground, right? Or else you're not going to be able to set it down. SpaceX is going to need to horizontally transport starships across the Gulf to the Cape, at least initially, until the Cape facility gets up and running. Chrome Kiwi had this picture from RGV, and Chrome started working on this thing, which we believe is the start of the breakover device. A breakover device is a really nice way of saying a thing that takes like starships and super heavies and turns them horizontal. It breaks them over. If I had to guess, SpaceX is probably going to do it with a crane. I was going to say, I was actually thinking, could you do it with a chopstick? No, you can't do it with the chopsticks. You can't do it. You can't. I don't think that'll work. Then again, those grid fins. No, they can't pivot that far. I was going to say, no, they're probably going to use a crane. I'll bet you, okay, so they need a regular bridge crane. I'll bet you they use the bridge cranes in the Mega Bay. That's probably it. So you'd have the bridge crane lift the booster up, put the breakover underneath it, right? And then you pull the breakover device, right? Something that allows for the booster to go like this, and then just lower the bridge crane. I think that would be the best way to do that. Look at the ship in this picture. It has some new holes where the SQD was. Maybe new SQD stuff or RCS. Oh. Those are for docking paraphernalia, if I'm understanding this right. Liv, those are for those are going to have something that kind of looks like Falcon Heavy arms. You know how Falcon Heavy center cores have those two attachment pieces, and then when it separates, they kind of fold up, right? I think that SpaceX is lifting that and using it as a docking mechanism. So, like, Starship's going to have something like this, and when it goes to dock to another Starship, right, it will, like, they'll both be back to back like this, and they'll dock up next to each other with something like that. Those aren't what Liv is talking about. Okay, look at the ship in this picture. It has some new holes where where the ship quick disconnect was. Well, that's a modified SQD for sure. No AP lines either, guys. From what I can tell, there's no autogenous pressurization lines. Those might be RCS right there. It's possible. Maybe. Oh, look up there. No, GC, I haven't heard about it. And then, guys, it looks like... What's that? 1, 2, 3, and 4. See that? What are those? Might just be the picture. It's a dual QD for refueling operations. Yep. Don't pay too much attention to the ship in this render. There's a lot of details missing. I was going to say there's no AP lines and stuff, and it looks like you're missing the apparatus for the rendezvous stuff. But hey, it seems like they finalized the boosters. Oh, boosters, very nice. Do you remember the scrapped V3 aft earlier this year? No, not really. Are the engines are going to be exposed like that? Yeah. Cosmo, instead of trying to shield the engines in a thermal protection system, SpaceX apparently went with, just integrate your thermal protection system into the motor to begin with, which actually isn't the stupidest idea. The reason why is because the engine already gets hot. That already gets hot. So just make the whole thing thermally resistant, and so you don't need an engine cover, which explains the simplification for Raptor 3's design. They didn't just simplify it for the sake of simplifying it. It's there for a very, very, very good reason. Could the tiles hit Raptors without shielding? It's possible, Falcon, however unlikely. I think the biggest reason why they went with steel grid fins is for iteration. Yeah, maybe. I mean, they started simple with grid fins for Falcon 9. Why protect the entire hot thing from heat? But could you protect the small things that can't get hot? There you go. How is heat shielding of the engines different than of the heat tiles? Tiles are not engines. That's a real good way to explain that. Won't the expanded plume from sea level Raptors damage the aft of the ship? I don't think so. No, you guys are losing me. You guys are. I'm losing the conversation. I don't know what Aitor, what does that have to do? What is the? We're looking at the aft end of the booster. What? Like, I'm confused. The lack of engine shielding is very ugly. Oh no, it's good. Do we know which booster these fins are going on, or are they simply non-flight hardware prototypes? Well, in the tweet they said it's the first grid fin for the next generation Super Heavy, so I'm gonna say that this is probably the real deal. Oh yeah, yeah, Chaz, I remember this thing. Yeah, this thing. Thank you. I remember that. Yeah, there's your umbilical. Ah, and there's your pins for the refueling starship. Yeah, I remember this. So much has happened. Probably outdated now. Yeah, maybe. What kind of shielding do you think we could expect right at the base where the engine plume comes through? What do you mean sedated? What are you talking about? Where the engine plume comes through? The engine plumes are down here. Guys, you're talking about when the booster comes into land. So, okay, a little bit on rocket aerodynamics here, okay? At the bottom of the booster, between the edge of the nozzle and the proverbial, like, bottom right here, so, like, the point where the engines mount versus where the engine shoots exhaust out the back, that's an aerodynamically stagnant point. In fact, in aerodynamics, it's called a stagnation point, okay? Basically what that means is that the air stays there and it doesn't really go anywhere. Now on ascent, it creates drag and low pressure gets kind of stuck there. Low pressure, high temperature air really gets kind of stuck there. The reason why is all the air is shooting, like laminar flow shooting like past this, and then the plumes are actually keeping it shooting down. So air kind of just gets stuck there. It kind of just creates suction and just keeps it there. Now, when the booster is coming back down, when it's flying through its own plume, same kind of stuff happens. Basically, it's flying through all the gas, and immediately the gas will basically pressurize, like, that's not pressurized is not really the right way to say it. It'll basically pressurize here, and then most of the jets that the hot gases that come out of the rocket engines get shot off to the sides. You have kind of a reverse of that stagnation here, but it's not as much heat as you might think because of how aerodynamics work. What is the diameter of Starship's plume? It must be more than 9 meters because the engines are sticking out. Well, Falcon, oh, jeez. Falcon, the plume really depends on your atmospheric pressure. The way the plume looks down here is going to be completely different than when Super Heavy shuts most of its engines off at like 2 minutes and 30 seconds. The ambient pressure is going to be completely different. So the plume is going to expand as you get higher and higher. Question about engine exhaust was the interaction of the ship engine plume with the integrated hot staging rig, I think. I don't know, Liv. I'm not sure if people are asking questions that are just off topic but pertinent to Starship, or if they're talking about the specific components. That's what I mean when I say people are. I'm losing you. I don't really understand where you're going with this. Like, I don't think there's going to be any problems up here. In fact, this is going to allow for much more airflow than what the hot staging rig design has. The reason why? Well, these are using cylindrical struts. Cylinders are very, 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 they're much more aerodynamic. Like if you have a column, right, and you have air shooting perpendicular to a column, much more aerodynamic than what they had on there before. I'll bet you they had, well, not bet you, they definitely had to deal with overpressurization happening in here, which is why they staged the engines the way that they did. I'm in the news, bro. Wait, how did I get on the news walking to class from college? Well, as someone that stands in front of a camera for long periods of time every day, Graham, it's probably because you stood in front of a camera. Big, if true. I don't know, man. I have a little bit of experience. They didn't ask you or nothing. It's called B-roll, and in your state, you don't have to ask permission to be filmed. That's only really a thing in like California and stuff. And the round cross-section for Strutch is much more structurally efficient. It's not really for aero. That's not what I said, Entropy. But yes, you're right, but that's not what I said. That I said that this during... Guys, why do you do this? Somebody asks a question that's not pertinent to what we're talking about. I go to answer that question, and then somebody says, no, that's not right, based off of the original thing that we were talking about, not the pertinent subject matter to the question that changed because the topic changed. That's not what I said, man. That's not what I'm getting at. Somebody was asking, like, if they're, is this going to hold, basically? Yeah, yes, it will hold. Is it going to hold during hot staging? Yes, it will be better for hot staging. Aerodynamically, it's better for hot staging, and structurally, it's better for the ship because of cylinders. My question is if the expanded plume of the shraps will damage the aft of the ship because they are spread out. The shraps. Okay. Sea level Raptors. My question is if the expanded plume of the sea level Raptors will damage the aft of the ship because they are spread out. Did I miss something? Is the engine configuration different for this Block 3 ship? Like, is it different? I don't understand. Aitor, I don't understand your question. I don't think they changed anything. Because Raptor, okay, so Raptor 3 has the same exact expansion ratio as Raptor 2 and Raptor 1. It's the same nozzle geometry, not necessarily design, okay? It's the same because it's using a similar what's called expansion ratio. Expansion ratio in rocketry is the shape of the nozzle, right? A higher expansion ratio yields you a slightly different shape. We're talking, this is in the context of what's called a de Laval nozzle. So basically the hourglass thing going on that all rocket engines kind of do, right? So as far as I can tell, Raptor 3's expansion ratio for sea level Raptor engines is the same as it is on Raptor 2. So the plume interaction, if anything, and Entropy, this is what I was getting at, dude. I understand the cylinders are more for structure, of course. But what I'm getting at is because the top of the booster is, the top of this right here is a dome piece, right? And you have cylinders that are perpendicular to your laminar flow, right? You're less likely to get pressurization inside of the hot staging ring during hot staging because of the free flow of air. This can flow a lot more air out of it, and because the cylinders with perpendicular laminar flow are much more aerodynamic than basically the cheese grater that they had as a hot staging ring, I don't think pressurization, I don't think plume interaction on the back of the ship or Starship or Super Heavy or anything is going to suffer. If anything, this is going to make it nicer. It's not going to be as bad as the staging with the hot staging ring on the Block 2 design. That's what I'm trying to tell you. Where are the ship catch pins? This render seems to be uncompleted. It's a much more finished render of the booster, less of the ship. So taking all that into consideration, where does the square hole go? It goes right up your... Yeah, that's where it goes. I'll give you a square hole. Why don't y'all take that badge and shove it up your... all up in you. Here, let me turn on SBL so I can audio. All right, so my headset doesn't time out. Will you be at Starbase for Flight 10? Probably not, no. Presume they will need a new launch license for V3 boosters. Yeah, maybe. You kiss your mother with that mouth? No, Cheeseburger, I kiss your mother with that mouth. Sorry, man, you walked into that one. Couldn't help it. I couldn't help it. I played Counter-Strike last night, and I'm in a spicy mood because of it. I'm sorry. I'm sorry. I'm sorry. I know I shouldn't have done that. I couldn't help it. Imagine that you at NSF. What do you mean, Falcon? So rude. Oh, boy. Take another week off? No, I'm good. I'm good. I'm good. Trash talking becomes a reflex when playing Counter-Strike. Yeah. Sorry about that. I hope you had fun. I really didn't. We did not win a game, Shaw. I did not. I really didn't. What's with the flat ends on the booster chines? Yeah, I'm not 100% on that, dude. I'm sure they're there for a reason, Conan, but I am having trouble guessing what that reason is. EJ, you played a match of Battlefield 6 where it's all snipers. Ew. Air brakes? Yeah, Matt, maybe. I don't know. Maybe, if we can, if my computer can run it. Sorry, getting a little too spicy. Something about bow shock? Not really gonna get bow shock. The bow shock would be over here somewhere. It's over here. Like that's basically dead air. That's more stagnation points up in here. It could be a thermal protection system element, dude. There's a very good reason. Like, nothing here is because it looks cool. There's a very good reason why SpaceX did all this. Like, look, the thermal protection system, you have a bigger thermal protection element on this side of the booster. Because, remember, per my paint drawing, this is the side of the booster. The bottom right here has that extra element. Actually, wait, that's on the sides. So that element would be like right here. Huh. Interesting. Yeah, that I'm not 100% sure about. Why does it look so good, though? I don't know, man. But that... yeah, that's definitely mint. They said that the actuators for the Gridfins would be inside of the fuel tank, so how would SpaceX prevent them from freezing? I think, Adrian, that there is an actuator-shaped, like, outcropping, I guess. I don't think the actual, like, Gridfin paraphernalia is submerged inside of the fuel tank. Yeah, I don't know, Aqualex. I don't know if it has that on the other side. We touched on why the outer edge of the Raptors are wider than Super Heavy. Tom, that's because the thrust vector range of these, you got 15 degrees of thrust vector on all of the 13 inner Raptors. If these things were if they were inset, so that the nozzles, like if you were looking at it from the top, the nozzles wouldn't be like outside like that. You wouldn't have as much thrust vector control. Yeah. The TBS is on the Gridfin sides. The only side without it is the same without the Gridfin. Yeah. That's so interesting. It makes sense because they only have 3 sides exposed while on a high angle of attack. Yep. Is the V3 stack higher than V2? I do believe it is, Falcon, just by a little bit. Wait, hold up, I missed something. Logan, hey, what's up, man? Just wanted to give you some love from inside Starbase. Love everything you do. Hope to meet you down here eventually. Wouldn't be working here if it wasn't for people like Tim, NSF, and you. Logan, my dude. Right on. That's awesome. Dude, this is some magic right here, man. That's a whole lot of magic. What do you think? They'll catch it? I think they'll catch it, sure. Dude, look. If this is just you guys, like, seriously, if that's just the grid, like the jig for just a Gridfin, can you imagine what the rest of the tooling looks like? I would lose my mind in there. I come in there and I see a Starship assembly line. I would lose my gosh dang mind, you know? I would Starship in my pants. Yeah, dude, what even is that right there? Like, what is that? What is this thing?
Discovery, go at throttle up.
That's called a gear. Sprocket. It's a doohickey. Oh, yeah, okay. That honestly looks like a airlock window or something. Wait a minute. No. Hold up. That's a pilot dowel. That's a docking ring. This is a docking ring. I don't think it's for fuel transfer, Hokey. This looks like a docking port. Like, for people to go through. Hence, like, why would you have this? Why would you have the acrylic? It's a round hole. Those are stringers, guys. If I'm looking at this right. Yeah, the next one, George, probably happened by the end of the month. It's white. White equals tooling. Yeah, maybe. Yeah, look at the pitch. Those aren't stringers. Yeah, I'm wrong. Or are they, dude? I don't know. I don't know what that thing is. That's definitely a pilot dowel. This is the type of thing that you'd use to line something up. Interesting. Will they catch booster 16 and booster 15? I don't know. I don't know, Hellfish. I don't know what that thing is. I'm at a loss for words here, boy. I don't know. Now I'm really wondering. Rotating tool to make something spin, which is a good trick. Yes. Guess on the first block 3 booster catch number. They're catching booster 18. They will catch it. That's the Space Waffle Maker? Yes. Pretty good, man. Does the Gridfin connect to that round thing for rotation? Well, like I said, Chaos, that is, yeah, that's definitely the rotation point. That's where the thing rotates. The Gridfin rotates through that, right? But check this out. That's the catch point. There's no more catch pins on the new booster. That's the catch point. This area, that's the point of contact. That's why this piece of steel is so thick in this damn design. That is where the thing gets caught. And that's why the welds are, there's so much weld going on in here. Over under on the first block 3, the block 3 first successful. I think it'll be fine. It's not the square hole? No. It's the round hole. It might be a window for something, Falcon. That's my guess, yeah. Wild how they made the catch point convex. Coltec, I'm pretty sure that's there to take into account that some of the grid fins might still be rotating during a catch within a certain nominal point of degrees. And that'll basically allow the ship to basically right itself, even if the grid fin's just a little bit off. All right, Ator, see you, buddy. What are you talking about? But Dojo, this is the SpaceX released new not renders. They released new pictures of their grid fins for the Block 3 booster. They did release a render too. Like, there's some renders for it. Also, note that those are painted. Just on a side note. Look at that thing, dude. So see this pad right here? See that pad? That's a catch point. That is the catch point. Now, you know what I'm really wondering, guys? Where my mind's going from here. Does the yaw grid fin have that? Maybe the yaw grid fin doesn't need it. Maybe it doesn't have that piece. I mean, the thing's huge. That's for the post-landing sway. That's what I'm saying, Yogbin. Yeah, they can compensate for the sway by rotating the grid fins. There's also a drive plate, though. I don't know. Yeah, it's not a render of a screen. Hey, you guys, squares. You guys are being squares or something. I don't know. Last. Okay. Idea: the gear thing is on the inside for the grid fin mount. That's the gear for rotating it. Maybe, dude. I don't know. Yeah, I'm gonna go ahead and guess, SpaceFax, that the yaw grid fin does not have this piece welded in. It's just, it doesn't have it. It's just that. It's just this triangle right here. It's probably, well, if it's rotating on that, dude, maybe, I don't know. That's a very interesting engineering trade-off here. Do you make the grid fins need this stuff to move? They need that piece to rotate. That's clearly where the point of rotation is, and that's clearly what bears the structural load of this thing, right? From whatever rotation thingamajig they're using, right? Does the yaw grid fin have a different plate in here, or do you just make it so you make one type of grid fin? Interesting design trade-off there. Yeah, Hellfish, that's what kind of tipped me off. Yeah, that's right. That's it rotates on that plate. Dude, do you know how strong the hinges for the damn grid fins need to be to hold up the whole booster? The whole booster weighs 300 tons. 300 tons! That's ridiculous. Yeah, Mutter, I'd say make them all the same. It's easier. It'd be easier to swap parts. Headset's running out of batteries. I could cook a massive waffle. Dude, I see the dude walking around in there, and all I'm thinking is like, yo, don't fall. Don't fall over. That would suck. That would really hurt. Can booster swing back and forth after the catch while the grid fins aren't moving? That would be fun. Yeah, I don't know, man. I don't know, but that's crazy. To be honest, the yaw Gridfin is probably oversized. They're just using the same design tooling now to build them fast. Entropy, that's my guess too, man. Yeah, make one type of Gridfin and just make a lot of it. It's the General Motors principle right there. Just make one thing, make tons of it. I can't believe that, dude. That is insane. Credit to SpaceX for posting this stuff. That's super cool. Yeah, the fixture's really nice. The grid fin and its jig are making me feel things, man. Holy shnikes. Like, dude, look. That's some eye candy, dude. Will those things have a ball bearing? Well, let's take a look. It's gotta have. I don't think it would have a ball bearing. I would say a roller bearing, if anything. Maybe even if you had two tapered rollers, the grid fin would basically want to ride in one spot. But then again, the load on this thing is really coming from the fin part, from the waffle iron part of this thing. So maybe it's probably going to be a bushing, low taper fade rollers. Yeah, Alex, now that I'm thinking about it, even a tapered roller probably was. I would just use a solid bearing. Solid bearing or a bushing or something would probably be much better. You would want some type of wear item in there because you don't want to wear the steel. No, Hammer. The Block 2 boosters had 4 grid fins that were kind of doing this. They were kind of like at 60 degrees off on either side, like that. This has 3 grid fins that are 90 degrees apart. Because you don't need 4. 2 grid fins can control yaw and pitch, or pitch and roll, and 1 grid fin can control yaw, and you're good to go. In fact, that grid fin, you could probably get away with using it for roll actuation too. So you could, at certain points in the flight, you could use these 2 grid fins for pitch control and that one for yaw and roll control. Actually, yeah, that's because if you deflect that grid fin too far in one direction or the other, it's just going to make roll. You're gonna roll. You're not gonna yaw. That's why rudders don't do this. Like on an airplane, they really only do this. They really don't have a lot of movement. Because if you make too much deflection over your center of gravity, right, higher than your center of gravity, so if you're looking at it from the side, if you have too much deflection up here, that's just going to cause roll. Like a rudder on a ship almost. You know, you turn a rudder, the ship's going to roll. I know hydrodynamics aren't aerodynamics, I get it. If the V3 booster and ship have the same weight but higher thrust, would that mean the booster would fall faster? No. Fall faster? No. It's not static, dude. So like your engines can throttle. So you can throttle the engines and you can change your trajectory. The speed at which it falls, right, really is dependent on its apogee. So how high does the booster go in general? How high is it falling from? Now the booster does have a terminal velocity, just like everything else, right? If I had to guess, that terminal velocity of something like this is probably somewhere in the 200 to 300 mile an hour club. Somewhere in there. It's not a club. Falling out of the sky. Yeah, I would say the terminal velocity for this is probably a little bit on the higher side. It does have a lot of mass, and it does not make a lot of drag. I mean, it kind of does, but... yeah, it's always going to fall at the same rate, dude. Everything's going to fall at the same rate because gravity's... yeah. Because of gravity. Everything about if an Epstein drive type breakthrough in propulsion happened, yeah, light through only all the time. Brachistochrone trajectories is what they're called, dude. Yeah. Oh yeah. I think about it more than I think about the Roman Empire. You're probably going to see the video, but a backseater accidentally punched out of an MAA and GF-15 on the flight line at Barnes this afternoon. Oh dear. That's anybody hurt, Tiggs? I'm hearing that Ship 10 is launching... Flight 10, not Ship 10, Matt Strutt. Flight 10 is launching between the 16th and the 22nd. Yeah, that seems to be about right. As I saw, no reported injuries. Yeah, that guy's going to have some back problems for a little while, Tiggs, but yeah. Anyway, that's awesome. That's really cool stuff. I do enjoy kind of talking through this stuff with you guys. This really helps put it into perspective. Just how this thing is going to work. And man, this thing's going to fly, dude. I think with Super Heavy, we might be past falling with style, man. I think she's going to fly. They still aren't Ming for a daylight splash aiming. For a daylight splash... yeah, it's going to launch in the morning, yeah. Honestly, good drawings. Thanks, Daytal. Putting that liberal arts degree to work, man. The black bottom parts of the struts of the hot staging ring, are those lifting points for the in-factory lifting or not? I don't know. That club had a falling out or a falling down. I meant like the pointy geometry of the actual grid. Oh, so Hammer, you're talking about this. Yeah. Every grid fin that SpaceX has had the pointy bits. That's how the grid fin maintains effective control. If it was just a straight waffle iron, right, and if you didn't have these curves right here, and specifically this point, this thing right here is what makes the grid fin move. you didn't do that, air would just go right through it. But you see the little flat piece right here? This little flat part of the grid fin, air is going to hit that and it's going to deflect. It's going to deflect into the square hole, right? So if you look at the grid fins, like, you know, just say that's a grid fin. We're looking at a grid fin from the front, right? If both sides of the fin, and here's like, say this is a 3/4 view, okay? Right? If both sides of the fin were flat like this, air would just go right through it. It would just go right through, okay? So, but because the sides are pointy, it has pointy sides like this, right? What happens with the fin like that, okay, is, let's just say we're looking at it from the side like this, right? What happens is that air is laminar flow is gonna come off of that, and the top of it is kind of, like I said, the top of it is flat. Air's gonna hit it and it's gonna shoot sideways like this. That little flat point at the top of every point on the grid fin hammer is superbly important. It needs to have that. If it doesn't have that, it's not going to work very well. All right, the bigger that surface area, the better, but you can't make it too big or else it's not going to really work. Now, what that does is it deflects air sideways. It deflects air into the waffle iron, so to speak. And that's what makes a grid fin a hypersonic control surface, right? Because you have air that gets pushed up against that, you get a point of stagnation here, and then air is going to shoot sideways off of it. It's going to shoot sideways into the sides of the grid fin. And the air shooting sideways through the grid fins like this, right? Instead of passing right through, the air is going to hit the front of the grid fin and get shot out to the sides. And say if this is the side of the grid fin with the box, right? Air is going to bounce around in there, and that's what gives you effective control. It deflecting the air down, because that makes that can vector the air in different directions if the grid fin turns, right? That point at the grid fin hammer is superbly important. The Falcon 9 wouldn't be able to steer if it didn't have those. Falcon 9 has them too. Yeah, and so does every version of Super Heavy that's had grid fins. That's all of them has had these. You have to have a point piece right there because that pushes the air into this. It shoots air through it instead of air. It deflects air into it instead of air going right through it. Because air going right through it isn't going to do anything. You're going to go to turn the grid fin, right? And air will just keep going through it. And it might kind of turn the air a little bit, right? But since you have the points, right, basically breaking the airflow and creating insane amounts of drag, that'll make a grid fin at high speed when it turns. It'll actually be able to move more air in a different direction because it's deflecting the air into these square holes. Does that make sense, dudes? That was kind of, I tried to keep that simple, but this gets into hypersonic airflow, which I'm not good at. Hey, Robbie. Yeah. Yeah, the hypersonic air goes into the square hole. That's right. The points create shock waves that move more air. Yes, that's how, because any control surfaces that are moving at like Mach 5, guys, if you want to deflect them, it's just going to make drag. That's all it's going to do. It'll just make tons of drag. You're just going to spoil the air. You're not going to deflect it. In order for a control surface to work, you have to deflect it in a certain direction, right? You can't just have air pass over it, right? It has to be able to shoot air downwards or shoot air in a different direction. That change in pressure is what makes the thing fly, what makes it move. If you're doing that at high speed with like a regular airfoil, air will just go right past it. It'll blow right by it. The grid fin breaks up the air. It's like a cheese grater for air. Think about like if you have a cheese grater and you take a block of cheese, you grate it, and it makes it into a bunch of little strips of cheese. That is what that thing does to air, and that's how it can control itself at Mach 5. That's actually, you know, I like that. I like the cheese grater analogy. Was that good? Can I use that? Now I'm hungry. Damn it. I like that. We should use that. It made sense, Hammer? All right, cool. I mean, it really is. That's what that's what it is, man. It's a freaking cheese grater for air. It's just designed to rip it to shreds so it can actually shoot it off in a different direction. Yeah, Reynolds number stuff in fluid dynamics, yeah. Yeah, it's basically a cheese grater. It shreds the air, and that gets it to slow down enough to shoot off in a different direction. I'm hungry. Yeah. As long as it's faster off the pad than blue. Freaking cheese grater. That's what it is, man. That's what it is. You know what? Hold on, I want to check something. There's one more thing I want to check. Yeah. Look, the yaw booster in the render has the catch point, even though it's never going to be used as a catch point. Fluid dynamics get weird at hypersonic speeds. Yeah, spoiled. Exactly. They really do. That's why that doesn't look like a control surface that you'd see on like an F-22 or an SR-71 or even Concorde, right? That's why it doesn't look like that. That's why it looks like a damn cheese grater. Because that's basically what it does to air. It shreds it into bits. And that's why, for instance, with Falcon 9, guys, that's why SpaceX chose to make them out of titanium. Because if you shred air to bits, it ionizes and it creates an insane amount of heat. So if the air slices of cheese, does that make it moon air? No. It's not slices of cheese, Big Pooh. It's strings of cheese. Okay? Differences. Cheese grater land's different for a certain percentage of the population. Why would you tell me this, Aqualex? Why would you mention this on stream? Why would you? You know what? I'm not asking. I don't want to know. Really don't. Nope. Not even genuinely, like, curious. Nope. I don't care. Nope. Nope. Vermunda. Nope. 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 I'm just going to go back to enjoying these nice renders. That's a good way to say that, Entropy, for sure. Yeah. How many tons of grated cheese could Super Heavy melt on liftoff? I don't think the cheese would just melt, Livin. We're talking, I think the cheese would ablate. And how much? I don't know. What's the specific heat of cheese? Like, what temperature do you need to melt cheese? All right. You know what? I'll Google that. Specific heat of cheddar cheese. The specific heat capacity of cheddar cheese typically ranges from 2.4 to 3.06 kilojoules per kilogram degrees Celsius. You'd need a lot of cheese if you wanted to make a launch pad out of cheese. You would need a lot of cheese.
Go and throttle up.
you'd need a lot of cheese, man. It would ablate. You'd have a blade of cheddar. It would either smell amazing or it would not smell great at all. Like Wisconsin or Vermont. So with cheddar cheese, there's a range. It's 0.354 to 0.481. 2.4 to 3.096 kilojoules per kilogram degrees Celsius, respectively, in compositional range of 30 to 60% moisture, 8 to 37% fat, and 22 to 36% protein. Thanks, now I want mozzarella. Well, mozzarella wouldn't be good because mozzarella is the aluminum of cheeses. It'll just melt. It melts and creates a stringy mess. Why does that analogy work? Why does that work? Aluminum is the mozzarella cheese of metal.
Discovery, go at throttle up.
What happened? What happened to us? Parmesan is my Frank's Red Hot, Ader. I'd put Parmesan cheese on everything, dude. Hot dog, good. Parmesan cheese. Burger, put some Parmesan cheese on there. Spaghetti bolognese, Parmesan cheese. Angel hair pasta. I'd put that stuff on everything, dude. You make Kraft mac and cheese. First of all, I have Kraft mac and cheese not because I need a gourmet meal. If I'm gonna make mac and cheese, I'll do it from scratch. But if you need something quick, Parmesan cheese. When I make my mac and cheese from scratch, Parmesan cheese. Just put it on everything. Good info to have since we are going back to the moon. Yes. Do you think the unshielded engines will have a noticeable aerodynamic effect? No, Drip, not really. Nah. Honestly, no. So you have a pretty gnarly stagnation point. I was talking about this a little bit earlier. Here, let me so like if we're looking at a side profile, right? So here's your outside rocket engine, right? Right? And here's super heavy. Okay? And then say there's a chine, right? This is a side view. You get a lot of stagnation in this area right here and in this area right here. Honestly, shielding versus not shielding the engines down the bottom really don't make a difference. The Saturn V had unshielded motors. Like the motor's turbine machinery was not like covered. They just mounted it to the back. Saturn V did that. Now, here's the thing. That stagnation point that I'm telling you about on ascent is this area right here. So usually the air is going to come off of this thing and it's going to go out. Why is the airflow here? I'll make the airflow a different color. Why is the airflow going to go out? Well, because you have the flames coming out of the rocket engine, right? Flames coming out of the rocket engine as it gets higher and higher are going to look like this, right? It's going to expand, right? And that's going to change the area of stagnation. The area of stagnation will basically be out here. Why is that? Because air is basically getting compressed up against the rocket engine right here, and it's staying there. It doesn't move, right? There's your stagnation point, right? And because the air just basically gets compressed there, yes, the motor does heat up, but SpaceX took that into account with Raptor 3 by actually just making the entire engine a thermal protection system, which, okay, right? So your airflow ends up going out here. And now you do have air that gets caught in here and in here. Once again, your stagnation points, and that air that gets caught in there is usually quite hot. But yeah, it's not going to really affect aerodynamics too much because this effect right here pretty much happens with every single rocket. It happens with every single rocket because every single rocket has a plume, regardless of if the engine is in or out, right? So you do end up getting flames that look like they're traveling up the side of the rocket. If you look at here, here, let's check my buddy Jerry here. You look at Jerry Pike's photos of 1091 coming into port, which is another bit of space news. The Kuiper 2 mission, right? The Kuiper 2 mission booster came back into the port. So check this out, dude. Look at the bottom. Look at the bottom of Falcon 9. It looks like they dipped the whole bottom of this thing in thermal protection system. It's for that exact reason, because fire will appear to travel up the side of the vehicle. Because there you get stagnation from the plume. because the plume expands, right? And then you get air kind of caught between the top of the plume, so to speak, and the outside of the rocket engine. And the oncoming air kind of pushes it in there, and it forces it into it just to stay there. Sorry, if you know aerodynamics better than me and I'm not using the words correctly, I apologize. I'm pretty sure I'm saying it right, but if I'm not, yeah, just bear with me. I didn't go to school for this stuff, but I understand how it works, but I just don't use the right phrase sometimes. My fault. I remember back when a kid could ride in the back of a pickup truck, there was a sweet spot that could literally take your breath away. Yeah, on a pickup truck. Some of you said that. That happens with a pickup bed. Yeah. Mm-hmm. Would you know the thrust to weight ratio of a Falcon 9 second stage for your research?
Discovery, go at throttle up.
Nope. I know it makes about... Merlin Vacuum makes between 900 and 1,000 kilonewtons of thrust, somewhere in there. I'm sure you could figure it out. Hey, Jasper, 65-month resub. What about the airflow when it comes back? Ooh, good question, Sivola. Yeah, here, let me go back to... All right, so here, I'll redraw the chine, right? So the air when it comes back. So the air is going up into the rocket engines, first of all. Air is going up into the rocket, and it's basically pressurizing in the combustion chamber, which basically pressurizes the nozzle. That's not a big deal. The pressure that the air going in there reaches is nowhere near what it is. It's nowhere near 300 bar, let me put it that way. So the Raptor engine will be fine. Now that does mean that some air is going to get caught up in here, right? And that's going to create stagnation like this. It's very similar, believe it or not. I know that doesn't make a whole lot of sense. And then basically what's going to happen is you're going to get you have a huge kind of pressurized point. Now, instead of it being low pressure like on the way up, it's actually high pressure, obviously, right? And then the boundary will go out like this somewhere. It depends on the speed and altitude and humidity, believe it or not. Well, not necessarily humidity. It's probably going to go out to the sides like that. In fact, I know it goes out at 45 degrees like this. Actually, if I had to guess, it's probably a little further back. It's probably somewhere like this. Actually, you know what? I can tell you exactly where it is. Give me 1 second. Now, keep in mind, the Block 3 booster, Block 2 boosters and Block 3 boosters are a little bit different aerodynamically, right? But, yep. Give me 1 second.
Water.
Yo.
Motion.
Yes!
So, fellas, see the plume? Look. See it expanding out? That's what I'm talking about. It starts to expand outward, and it appears that fire travels up the side of the vehicle. Now that's probably glare from the sun, but you get the idea. Sounds very aerodynamically unstable. The Gridfins are far enough away to get laminar flow. Sivola. Yeah, that boundary will go out and it'll come back in. It'll come back in basically probably. If I had to guess, it's probably where the end of the chines are. It's just a guess. But once again, that depends on speed and altitude.
Oh my god, gosh, look at that thing coming at us.
Yeah.
I know it does. I know.
Here it comes.
At the very beginning of that video, what's shooting out of the ground side? Water, 619.
It's
the
a
suppressor.
coming. Dude, Adrian, it's a...
Guys, I dream about this. I'm not even kidding. This is Flight 7. I still have, I was there. I still have dreams about this. Like, that, the booster coming back, specifically, like where it shoots through its own plume and it looks like an ODST troop from Halo, like dropping down and then landing, that is sci-fi in real life. It is, I dream about this thing. Even now, this was 8 months ago. It's burned into my memory permanently. Like, I'm just like the Falcon Heavy landing was, first Falcon 9 landing. I was at those. I was at the first Falcon Heavy test flight. I was there for the first double landing, and I was there for the first single landing. I wasn't there for the first super heavy catch. I was there for the second one, though.
approaching pretty quickly.
Yeah, baby.
I'm gonna move over here. It's easier to see it. I dream about this. This dude, look at. Oh my God, that's cool.
Come on.
It's punched through the clouds. That's awesome.
It's really
Fly, baby, fly.
So look, Civola, look right there. See it? It's gonna. So the air is gonna get forced out, but it's going to come back in because ambient pressure is gonna push it back in. You can see that the curve right there from super heavy is starting. It goes out and then it starts to curve back in, right? And guess what? It's gonna curve right back in up here. It'll kind of look like a teardrop almost. If you kind of extrapolate what a teardrop would look like, if this is the very bottom, it's going to come out and it's going to go right through the grid fins. Oh.
Oh my God!
Come on. Do the thing, do the thing.
See it? Very defined right there. Look at that. Look at that, man. I saw this. We saw this. Oh my goodness. Do you think the failures of Flight 7, 8, and 9 have the same reason? It can't just be a coincidence. Nah, it's all different things, Falcon. Oh. And yeah, you can see the shocks coming off the grid fins as well. And that's what I mean. The grid fins are turning the air. You can see them right there. Not this so much. That's coming off the very top of the booster. It's these little guys. See these little spiky things in here? Right in that area right there? Those are the grid fins. The grid fins are doing that. You can see that they're changing the pressure of the air. That's why you get these vapor cones here. That's what they're called. They're changing the pressure of the air because they're being used for effective control. They're turning. Now, see this right here. This one is the flow separation that's coming off the very, very top of super heavy. Dude.
Yes. Come on.
Seeing some vapor on it.
Some, dude. Yeah, see? It's super defined here. God, man, so happy that DOS and Airbor's have this footage, got this footage for us. See, look, you could see the teardrop almost. Isn't that cool? This is awesome. I never really, stared at this footage like this. Look, you can really see the grid fins doing work there. Look how one of the vapor cones is bigger than the other. That means that it's changing the pressure more because one of them's bigger, right? So one of the grid fins is actually turning in this picture. That's pretty neat. That's pretty neat. I never noticed that before. I've watched this footage tons of times, dude. Where's this from? Willie, this is from the top of the Margaritaville Hotel. It's about, I don't know, what is it, like 10 miles away? Yeah, I was there with Das, Gene, and Gene's buddy, Sean. Not Sean, but Sean. You know him. He's in chat sometimes. And dude, this was the first super heavy catch I ever saw. It's the second one that SpaceX did, and it was such a clear day, dude. It was perfect.
Oh.
Come on, baby.
Come on. Light it up.
Seeing some vapor on it.
Oh,
Come on, baby.
come on, light it up. Yeah!
We got a light.
So, yeah, you can kind of see the stagnation point, guys, because there's some flames behind the engines in this frame. You see that? You see some flames that are happening. So when the rocket engine ignited, some of the flames, dude. The gas is being shot out from the rocket engine is actually making its own vapor cone. Yeah. The engine exhaust is pushing the air out of the way so much that it's causing a deep momentary depressurization, which is why you see this condensation here. But you see that there's flames behind the engines? There's the stagnation point. And then it's going to shoot it off to the sides.
It's coming down, it's coming down.
Come on.
Oh, it's slowed way down.
Shut the other engines off. That's what those flames were.
Down to 3 engines.
Come on, bring it on home.
Dancing over there like it's nothing.
Come on, baby.
Yes!
Oh my. Yes! Oh my goodness.
That's pretty good. That's pretty good. That's pretty neat. Dude, I love the air horn. Dude, somebody went bananas with that thing, dude. We saw an SRB from Ariane 6 glowing in the night here in Quebec. Believe it touched down somewhere nearby. Really? Huh. Thank you for the explanation. I was thinking on return if the engines could have a Gridfin-y sort of effect. But I guess there isn't much room for the bottom of the booster that is an engine build. Yeah, Driplord, you really wouldn't want a control surface up there because... okay, so you got to think about super heavy. Where is the center of gravity, right? Where's the COG when you have 5% of fuel? Like, on the way up, when Starship is ascending, right? The center of gravity is somewhere, like up here somewhere. It's up there because you have a full tank of methane and you have a full tank of liquid oxygen, right? But when the thing's coming back down, oh.
Here we go. We can see the glow.
Oh, sorry, I get goosebumps looking at that every time, dude. But when the booster's coming back down here, the center of gravity is quite low. It's down here somewhere. Why is that? Well, there's 33 engines down there. Raptors are pretty, they're pretty stout little motors, and they actually are kind of small considering the power that they put out. Their thrust weight is insane. But because there's 33 of them down there and all the plumbing and everything associated with that, I mean, this is mostly hollow space up in there, right? So the center of gravity is actually quite low. A control surface up here at the front of the booster, right? If you had like a set of grid fins up there, it wouldn't really do much. The reason why is because it doesn't have much effective moment over the vehicle as it's flying. What does that mean? Okay, let me get a model airplane that I have on my shelf here. Okay, let's take this. This is one of my favorite planes. It's an F4, right? Now, I know that if you're an av geek, the F4 is not really your, like, role model plane for aerodynamics. I understand that. But, so look at an F4, okay? Where are your control surfaces on an F4? Now, the wings, right here, your main wing element, that's there to make the plane fly, right? That doesn't mean that you don't have control surfaces on here. There's ailerons on an F4 that are right here and right here. But the ailerons are there because they're on the farthest point away from the center of gravity of the plane. Center of gravity of the plane's down the center. So if you want a roll control surface to make the plane do this, the further that surface is away from your center of gravity, the more effective control it's going to have, right? Now, for pitch, that's roll. Roll is this way. For pitch, doing this, right? So drip, where would you want your control surfaces for pitch? You want them as far away from your center of mass as possible. which is why your elevators, these things, are at the very, very back. They're behind the damn engines in an F4's design. They're as far back as they possibly can be. The reason why is you get more effective control that way. If you had an elevator, the same control surface, here on the center of gravity of the plane, it wouldn't do anything. Because the plane, when it's flying through the air, usually rotates around its center of mass. Or center of gravity, right? Now, like I said, you can usually figure out where the center of gravity is on an airplane because of where its landing gear are. All right? Its main landing gear, not the front. The center of gravity is usually in front of the main landing gear. Because if it was behind the main landing gear, you'd make a tail dragger, right? So an F4's center of gravity is probably somewhere right around here. Just in front of the rear gear. So, what's the farthest control point from this area right here? Boom. See, that's the furthest part away. Now, something like super heavy. Give me one sec. Something like super heavy, right? This is an old version. Your effective control is back here. But if your center of gravity was right here, having a set of grid fins up at the front, great idea. You could really make this thing move. Kind of like a Sidewinder missile. A Sidewinder missile has control surfaces in the front and stabilizers in the back. See, stabilizer. Right? Stabilizer. Good stuff. But super heavy, when it's coming back and it doesn't have a lot of fuel left and oxidizer left in it, its center of gravity is somewhere over here. What's the furthest point away? The grid fins. So the grid fins are going to have great effective control. Now, Drip, you could put a set of fins up here, and I'm sure they would do something, because they aren't directly on your center of gravity. They're a little out in front. But even if they could rotate on the same, if they had the same amount of what's called deflection, like how much it can rotate in one direction or the other, even if it had the same amount of deflection up at the front, it's leverage here. It will, in physics, it's called moment, all right? You're not going to have as much moment if you try to affect this thing if its pivot point is where my pointer finger is, right? But Archimedes, give me a lever long enough, right? Out here doesn't require nearly as much work to get the thing to turn. See what I mean? So you could put a grid fin up at the front. It just wouldn't really do much. Yes, F4, super heavy. And yes, that's a Sidewinder missile stabilizer. Yes, it's an old Sidewinder missile stabilizer, which is why I have it. Get right, 6-month resub. Thank you. Jasper had a 65er in there, and Argo had a... Argo? No way. Argo had a 33-monther in there, dude. Sorry, my headset is going... Yeah. What's up, guys? Dude, there's a lot of old school viewers. Thank you. Appreciate you. Somehow I'm not surprised that you have this. Oh, you want to see something cool? Sidewinder missiles have a stability assist in it. They have passive gyroscopic... Oh, older ones. This is a very old design, which is why I have it. Older ones have a passive stabilization. Passive gyros. Yes, you heard that right. Passive stability assist. When the missile's fired, this little tab
Discovery, go at throttle up.
opens up. And that allows this to do that. See that right there? Kill! Right? It allows it to move. So how's that a stabilizer? Well, if you look at the top, there's two aerodynamic elements right here and right here that channel aerodynamics in aerodynamic forces when the missile flies through this little spinny wheel here. And aerodynamic, the air shooting over this thing causes this thing to spin and turn it into a gyroscope. So if the missile turns, right? If it turns to the right, this thing is going to turn this way. It's going to turn in the opposite direction that the missile is moving, and this gyroscope that's being spun is actually going to stabilize it. That's why Sidewinder missiles can do all these crazy maneuvers, because they're passively gyroscopically stabilized. Yeah, pretty cool, huh? Yeah, I have it. You don't? You don't have one of those? Who sent that to you? I don't know. I got it at the same place I get my pants from, dude. Now, once again, if people are wondering, like, should you have shown that? That's an extremely old missile. It's that tech is long useless. Oh, it can turn. They have other ways to do that now. Don't worry about that. You don't need to worry about that. Can I have it? No, it fell off a truck. Yeah, that's right. Now that you have an air compressor, you could spin up the roller-ons and show how they work. Excuse me. Working. It needs to take a second to build up pressure, guys. I don't keep my tank at pressure because of condensation. It'll rust it from the inside out. Contact. It's going. Oh, it's going. Didn't go for very long, though. I got another idea. WD-40? No. No. See this? This is the good stuff. Just drop a little bit. Drop a little bit of that in there. Drop a little bit of that, all up in there. Oh, yeah. Oh, yeah. Is that food coloring? That's not food coloring, damn it. It's lubricant. It's industrial lubricant. Now watch it spray all over the office. Yep. This is going to get loud again, so just... See how it moves? And when it stabilizes it as I turn it, isn't that cool?
Throttle up.
Can't hear it? Oh, no. We're just going to have to do it again. Hey, House, 8-month resub. Hold up. So, I'm turning the suppressor off, okay? Headphone users. The noise that this is going to make is going to blow your speakers out if you're not careful. Okay? So watch. I'm going to spin it, and then I'm going to turn it. And watch what happens when it turns. Okay? Watch this. Oh, here it comes. Oh, it's going to be a rot. That's awesome. Pretty cool, huh? Haha. Dude, did you hear that freaking noise that made? But did you see when I turned it, when I moved it even a little bit, the thing immediately went out and it stayed there until I stopped. And then when I stopped, it moved back. Did you see that? That's really, really smart. Passive gyroscopic stabilization. Pretty cool. All right, we got to. All right, one more time. Pretty cool, huh? See how it's, dude, look. See how it stabilized itself? Dude, it sounds like dental equipment, man. Your ears hurt. I told you to turn it down. All right, I'm not doing that again. That's good enough. Oh, that's refreshing. Okay. Yeah, my new air compressor is quite good. It's pretty awesome. no hair. Just draining the compressor. Now I'm turning the compressor back on. The mic compressor. Is that cool? Yeah. In case you were wondering how much pressure I hit it with, 10 bar. Yeah. 150 psi. Yeah. We hit it with 10 bar pressure. And this is air tool lubricant, in case anybody's wondering. That was peak neuron activation. Dude, the noise that thing made. That was awesome. Cyborg, that was a good idea. I knew I liked you. Fun fact, you can do it in Kerbal. Man. Now think about the fact that you have a real piece of a Sidewinder. Yeah, that's pretty cool. I do like that. Any other random cool stuff you could just randomly pull out like that? Oh, I organized all my random and cool stuff, Daves. That's what I did. That's what I did during my break. You know, that's where I've been.
Discovery, go at throttle up.
This stuff's pretty cool. Here, want to see something neat? Here. Have you been coined by the 45th Space Wing? I don't think so. Get coined, nerds. Here, how about this one? That one's pretty cool. This is a piece of nose gear tire that flew on Atlantis in Colombia. Nice. How about this one? Piece of the MLI from STS-86. Yeah, that's pretty cool. How about this one? No, I didn't get mine from eBay. They show up at my door, dude. That's a piece of Columbia. That was its last mission before STS-107. Here's one that I'm particularly proud of. Where's the rest of the missile? I don't know. It doesn't know where it is. I love how you could just you could pull the most random and cool things out of thin air and say nothing about it. I got more cool stuff. I mean, some of it I can't show. Trying to think. What haven't I showed on screen before? Let me try this. Now I show that. Here. How about this one? Collect the stuff like comic books. STS Flight 1 Overview Report. That's pretty cool. Look at, I got more stuff. How the heck do you get that? No, we're not opening this one up. No. No, we're not doing that. This one doesn't get open. I'm sorry, Dave. I'm not showing you that. Here, look at my 45th Space Wing Challenge coin. Get coined, idiot. I messaged you. Okay, Trey. I messaged you. As a War Thunder player, no. It's not classified, guys. I just don't prefer to show that on stream. If it was classified, I wouldn't have been able to get my hands on it. All this stuff was procured legally, and it is all declassified. But I'm not showing MPS stuff on stream. Sorry, we're not doing that. we're not doing that. I have the paper trail, dog. You can find all of it, Blaz, on. You can find it on eBay, dude. I didn't get it from eBay. I wasn't kidding when I said this stuff just shows up in my PO box. You know, like just shows up in my PO box. Like that Titan II missile you have from eBay? I don't have that. Why are the Falcon 9 grid fins curved? Because they fold up against Falcon 9, which is cylindrical Falcon. EJ, I have a question. Could that work for a spacecraft going to Mars to fly on Mars? Chris, there's not a lot of air on Mars, and there is some, but there's not a lot. No, you'd probably need an RCS rather than the gyro stabilization, because the gyro stabilization needs an atmosphere to work correctly because it's aerodynamic gyroscopically stabilized. But it's a passive system. There's no computer controlling it. Physics controls it. The computer is controlling the canards on a Sidewinder missile, if you really want to know. Green screen, you doofus. You doofus. Here, you guys want to see one more cool thing? I'll show you one more cool thing.
Discovery, go at throttle up.
Starship flight tile, flight 1 tile, and then Solo, what's up, man? I see where I'm missing landscaping when I want it back. No, sorry, I can't do that. It's nothing I can do, no puedo. How do you get your hands on this? I know people, dude. Now, okay, full disclosure, this is 3D printed. This is a 3D printed replica of a tile. This is not real. But, I mean, look, the serial number is EJ154 on the back. E3572-154J. This is a fake. But it's good for showing people about the size of the tiles. It's a replica, it's not real. That other one though, oh, that's real. What's more probable, Space B-52 or the Jets winning a Super? Space B-52. You don't even need the last part, Enzo. What's more probable, Space B-52 or the Jets winning? You don't need a Super Bowl part, because let's be real, that's not happening. That's not happening anytime soon. Adam Savage has a space shuttle video. Yeah, I saw it, the engine. Falcon, they just showed HLS window. You could see glass inside. Well, who's they? Let's just make it a wreck. Cowboys Jets Super Bowl. All right. Man, that's cool. No, we want a Jets-Browns Super Bowl? I don't think we do. I don't think we want that. Now I'm looking through the Starship pictures that I started to accrue and then stopped because there's way too many of them. Jack Byer. Yes. Oh, dude, look at the old Menace logo. Why did it take NASA a Saturn V to send Apollo to space, and now it takes a Falcon 9 to send Dragon to space? So, give me 1 second, Joe. I can explain that. So, okay, Joe. So, why is a Falcon 9 smaller than a Saturn V? And it is. It's way smaller. Well, the Apollo is going a lot further. Now, okay, Joe, the reason why I needed to, like, kind of collect my thoughts there for a second is because, rocket science is a little weird, okay? So what does that mean? Okay, so if you want to understand, okay, so obviously I could tell you the Saturn V is designed to move the Apollo capsule and the lander, which are, let's just speak in during the few moments that we have left, we're going to talk right down to earth in a language that everybody here can easily understand. No, all right, so just speak in layman's terms for a second. The Saturn V, first of all, is moving the LEM. It's moving the lander and the capsule. So it weighs more. Now, in spaceflight terms, bigger mass. It's higher mass. Now, the second thing is, we were talking layman's terms, the moon is 250,000 miles that way. Okay? The space station is 270 miles that way. 250,000 miles, 270 miles. You want kilometers? I don't know what 250,000 miles would be in kilometers. I don't know, 400,000 kilometers maybe? Somewhere around there. The ISS is basically 415 kilometers circular that way. About 270 miles, give or take. Those numbers are rounded, etc., etc. So it's further away. So you're moving more stuff further away. But Joe, that's where the layman's terms end. Now, with rockets, dude, you don't generally speak about how far a rocket can go in distances. Rockets' range aren't measured in distances. A car is, like if you think about an automobile, oh, it has 500 miles of range. My Tesla has, 300 miles of range or 400 miles of range, whatever, right? You think about it in distance, right? Because it's point A to point B. In space, that doesn't really apply. The reason why is because you have to deal with acceleration all the time in space. Gravity. Gravity is an accelerated force, 9.8 meters a second per second, or 32 feet per second, right? It's an acceleration. Because of that, right? because you're dealing with what's called gravitational perturbations. Basically, there's grav wells. You have to go fast enough to get to orbit, right? You have to accelerate to a certain speed to get into orbit. And then you have to accelerate to to another speed to get to the moon, right? It's not really measured in distance. What you are measured in with spacecraft range is change in velocity, or delta V. How much you can change your velocity. If you can go faster, you can go further. That's why I like rockets. It's not necessarily about how far it could go. It's how fast you can go. Okay? So the Saturn V needs to be able to accelerate that higher mass payload, because you have 3 dudes in a capsule with a service module, right? And then you have the lander, the LEM, on top of that. The Apollo CSM is 25,000 kilos. The LEM is 16,000 kilos. That's a lot of stuff to move, dude. And not only that, but the Saturn V needed to accelerate all of that to, you know, it's about 23,000 miles an hour. So think about that for a second. In order to go further, you need to be able to go faster. The Saturn V could push that 40 tons of lander, 40 tons approximate, it's of lander and capsule, and with 3 dudes on board, to about 23,000 miles and change. 23,000 miles an hour and change. That's crazy. That's why you need a big rocket, because you need to be able to go faster if you want to go further. Iger, you saw Living Color on Lansdowne Street in Boston when EJ was 5 years old. I exploit you, still you love me. I tell you 1 and 1 makes 3. That's a good song, man. How much more payload would Starship be able to carry if it was a fully carbon composite vehicle like it was going to be? Would that have made a difference? Tanner, you might be able to go a little bit further, because the flip side of the delta V equation, and like rockets in general, is that you can make a bigger rocket to go further, but the rocket equation has to do with what's called a logarithmic, it's a logarithmic function, and that function is between the dry mass and wet mass of your rocket, or initial and final mass. All right, it's a logarithmic equation about the relationship between how much mass is the rocket when it's fully fueled and how much mass is the rocket when it's not fueled. Okay, specifically because it's logarithmic, the relationship between wet mass, or initial mass, and dry mass, or final mass, right? The further that relationship is apart, the further it favors you. So a plain English way of saying that would be, the less rocket you have on your rocket, right? And the more fuel you have on your rocket, you can go further, right? Per the delta V equation, it's not about going further, it's about going faster, right? So if they were using carbon composite structures, it would be a little bit less mass, right? So you would get an efficiency increase. The reason why SpaceX didn't want to do carbon composite structures for it is because it doesn't really favor reuse. It doesn't favor reuse on the scale that SpaceX wants to. Now, what does that mean? Okay, when I say reuse, I know what people are going to say. Well, what about Neutron then, EJ? Rocket Lab's doing it with carbon composite. They seem to be getting along pretty well. Well, yeah, of course. Sure. But when I say reuse, I mean hours. Hours. That's what SpaceX is trying to do. Launch a Starship every couple hours, like an airplane taking off. And part of that reusability is having a high concentration of Starships. Having a lot of them. So now you're bringing in mass production into what's called a stakeholder expectation. Stakeholder expectation is a variable of systems engineering, specifically rocket systems engineering, or just any systems engineering. Like, basically, your stakeholder expectations for a rocket are like if you're playing a game of D&D, right? You're playing a game of D&D, anybody that's played D&D knows that every campaign is different. Every campaign is slightly different. There's a different rule set for every campaign. And that rule set is, invented by the dungeon master, right? So the dungeon master comes up with the rule set, and they're the one that kind of oversee the game. The stakeholder expectations are your rule set for your rocket. Now, how that translates to rocket science is, okay, the plain English way of saying it is, what is your vehicle trying to do? What is your vehicle trying to do? That's really important. Saturn V, very clear expectations about what that thing is supposed to do. Anybody here could tell you what that thing was designed to do. It's designed to go to the moon. I'm pointing over there like the moon's over there. That's some guy's desk, right? Space shuttle, what's its expectation? It's not so clearly defined. It's more of a gray area, which is why we ended up building a space station with it and then being like, right? With Starship, the vehicle expectations are very clearly defined. This thing is supposed to be Starship is supposed to be an avenue, is supposed to be able to establish an avenue between Earth and Mars, going to Earth and Mars on a routine basis. Similar to, like what the 707 did for airline travel. It's supposed to be just, you could send people to and from Mars. That's what it's supposed to do. And if it's supposed to basically create a self-sustaining city on Mars. And in order to do that, you're going to need to move a lot of people. You're going to need to move a lot of supplies. You got to build a city. Building a city is hard to do here, let alone on another planet. So your stakeholder expectations there mean mass production. You got to build a lot of these damn things. And because you're about to build a lot of these things, and because of orbital mechanics and the delta V equation, et cetera, right? The quick way of saying this is that you want to go to Mars when it's closer. Mars and Earth get close to each other every 26 months. That's a very layman's way of saying it. I understand orbital mechanics. I understand phasing and ejection angles. For anybody that's a nerd here, I get it. I understand. I'm trying to be straightforward, okay? So because they only get near each other every once in a while, you have to be able to launch a lot of ships really, really fast, refuel them, and get them to Mars in that small window when Earth and Mars get near each other. They only get near each other every 26 months. That is the most efficient and the most opportune window to get there, right? Where the delta V equation where we have a rocket that can actually make it there. It's easier to go when they're close. And because of that, you got to make a lot of these things. SpaceX is thinking about that. Carbon composite structures take a long time to make. They're not, it's hard to mass produce them. Even Rocket Lab would tell you that. They're hard to mass produce. That is one of the reasons why Starship switched to a stainless steel design. First of all, there's a lot more people out there that know how to deal with stainless than carbon fiber. Second of all, stainless steel is very, very inexpensive to purchase comparatively to carbon composite and carbon fiber structures. Very easy. You could go to the store and get stainless steel. You could go to a grocery store. You could buy stainless steel from the grocery store. It's in the form of a pot and a pan, right? But you could do it. You're not going and buying carbon fiber cookware, are you? Right? Stainless steel is way more readily available. And that favors SpaceX's stakeholder expectation of being able to mass produce starships. Does that make sense? That was a long answer, and I know that wasn't exactly what you asked, right? But how much further would it have gotten? Yeah, you would have gotten some marginal gains. The ship would have more delta V because carbon composite is way lighter than steel. In some cases, it depends. But that's the reason why SpaceX switched away from it is because it's hard to mass produce it. It's hard to mass manufacture that stuff. That was a good question, dude. Tanner, that was a good question. That was really good. SpaceX reusability is more on expendable fast build material, stainless steel structure with refurbished Raptors. Yeah, exactly. They're using stainless because it's readily available, it's cheap, and you could buy a lot of it, and you could use that to mass produce starships. You need to prep for bed. All right, Graham. Carbon fiber is only good for submarine. I disagree. You could do rapid prototyping with different alloys of stainless. Yeah, you can. And limited life support on getting there. Saturn V versus command module weight. Oh, the CSM was heavy, dude. It's one of the heaviest spacecraft, save for the brick with wings that was the space shuttle that we've ever launched. I mean, that is a heavy freaking capsule because it's designed. It's using fuel cells. It uses fuel cells. There ain't no solar panels on the CSM, right? It was using fuel cells, and because of that, it was really only limited to maybe a month in space. You've run out of power and oxygen if you go any further than that. Please, my question about the future of space explorations, read up, please. Please, go to bathroom, please. Rocket tech is not new, but the advancement in the last year is huge. It's still a niche. In analogy to cars and planes, one day it's going to be available to all. Question 1, when do you think that's going to happen? Could happen in the next 10 years if the industry is going the way that it's going. Janet, it doesn't seem like we're gaining a lot of momentum right now, but right now what we're doing is essentially in the US, we're building out the commercial industrial base to make rockets more like airplanes, which is crazy. That's really cool. I mean, SpaceX is kind of spearheading that whole thing, but it's pretty good. What regulations would there be? Honestly, the FAA, Tenet, has already started basically treating rockets like airplanes. Adopt airplane rules and regulations for rockets, and yeah, you should be good to go. That's basically what's going on. We're already moving in that direction. Hey, Real, 15-month resub. Just got back from a trip to Orlando. Got to watch the launch on Monday. All right. Good stuff. Sedated week. Hey, $10 super chat. Just keep being you. I'll try. I might need to. I'm starting to think that taking like a complete detox week off, like every 3 or 4 months, might not be the worst decision. I really don't. Up until this point, guys, I really don't take vacations. I take a week in July and a week in December, and that's about it. Those detox weeks, though, have me kind of reinvigorated. Look you can see the vigor that I am acting with. What is this executive order? Dummy, we've been telling you this for years. Yeah, but I'm not a... I like working, Jim. Okay? Oh, okay, Andrew. Yeah, I got you. I don't know. I think the mass of the Saturn V, or the weight of the Saturn V at liftoff was somewhere north of 7 million pounds. And the command module weighs like 55,000 pounds and change, I think. So 7 million versus 55,000. There's your ratio there. The Vega was from the fumes of the burning motherboard. Would Starship sort of be like a Mercury rocket to the Apollo for the moon, but moon being Mars? Golly, I've always thought that Falcon 1 was SpaceX's Mercury program. Falcon 9 is SpaceX's Gemini program. Starship is their Apollo program. What did NASA do? NASA used a bunch of converted ICBMs to do the Mercury program, right? And then with the Gemini program, they took more ICBMs and learned how to work and live in space, right? And then they used that to do Apollo. The Gemini program was just just learning. Falcon 9 is just the learning phase for SpaceX, if you want my honest opinion. After doing this for over a decade, I think you've earned at least 3, if not 4 paid vacation weeks a year. Dude, you need Membies on here. Not sure if it's easy to set up, but you need to. Okay, Matt, yeah, I keep saying I'm going to do it, and then I don't give myself a message or anything. I will set an alarm to do this tomorrow before we start Space News. There. I set my alarms. We're going to start Space News at 5. I set the alarms at 4:30, and 4:45. All right? This is for VOD continuity. I will work on that membership stuff tomorrow. Do you think they have a shuttle in the future, or Starship the end of the line? Starship is the shuttle, dude. It's the shuttle, it's the lander, it's the transfer vehicle, all rolled into one. And if that sounds complicated, yeah, probably is. Not streaming tomorrow afternoon? I'm not sure. We'll play it by ear, all systems. I'm trying to finish Bluefist. I'm trying to finish working on the blue truck. And the parts said they were going to get delivered yesterday. And they, you know what? They, in fact, did not get delivered yesterday. If you guys are wondering the status of that project, I said I would give you updates. What we're doing is we're getting rid of all the vacuum control systems on that truck. It's an 87 F350. We're getting rid of all the vacuum control systems because there's a vacuum leak somewhere and I don't feel like trying to fix that. So instead of trying to troubleshoot and diagnose the vacuum leak with a dwell gauge, we're removing all of it because it's emissions exempt at this point. Because it's a super old truck. So we're waiting on gaskets because we put a new intake manifold on because we don't need the smogger intake manifold anymore. So this is what it looks like right now. I redid the valve covers. I painted them Ford blue. The breather had a vent tube that went into the air filter before, but we switched to an older conventional style breather with just a regular PCV. I capped off the EGR system in the back. And I went through and scraped and cleaned all this stuff. Well, the valley was covered, don't worry. And I went through and basically made sure that this is spotless today. Put an Edelbrock on it? No, not an Edelbrock. Wyand. We're waiting on the gaskets for the Wyand right now. That was right before we put the valve covers on. I put them next to it because I wanted to get an idea what it looked like. But in the movies like Star Trek, it's so easy to go to space. I don't understand. It's easy to go to space when you have dilithium crystals that can generate insane amounts of energy, Tanit. We need better propulsion if we want to do stuff like Star Trek. But Starship is good in the meantime. That's fine. Do you think 3 Gridfins will help with the booster with directionally flipping? Nah, at the altitude that the booster flips around at, Falcon, I mean, unless they're going to pick up on some of the hot staging, like Starship's engine plume, to turn it, which they've done in the past, I'm pretty sure. I'm not sure if that'll help too much. So, I got a Wyand, and then what I've been doing here in lieu of not having the gaskets is getting all the fittings ready to go and all the vacuum stuff that we need capped and put in the right spots. But yeah, that is going on here. Should be happening tomorrow. I want to finish this and then we'll kind of get back to the regular schedule, okay? If anyone cares. Yeah, Falcon, we can do that. But yeah, this really shiny thing, it's kind of triangle shaped, is going in this triangle shaped hole. Put a supercharger there instead. You'd have to tell her not to do that. What size motor is it? That is a 460, so a 7.5 liter V8. How significant is Flight 10? Do you think the number of suborbital failures adding up is meaningful? No, false. Not really. Once again, if you think about Starship as a huge, like the entire construct of the Starship program, right? 3 flights, not doing too well, whatever. Starship is supposed to fly hundreds of times. That's going to be an inconsequential statistic in a number of years if SpaceX has their way. It's really not a problem. In fact, I think flight 7, 8, 9, and then 10 happening soon all these are just doing, they're just stopgaps for Block 3. That's it. They're just stopgaps. All SpaceX has been doing is biding their time till Block 3 comes down the pipe. I think Block 3 is going to fix most of the problems that they have been encountered. In fact, I think they're using these Block 2 weird ships as prototyping, which is why we see a high failure rate. I think they're using it to learn. They're basically bug testing the Block 3 design without actually building the Block 3. And what they've learned from the data from Flight 2, save for the Ship 36 explosion, what they've learned from Block 2 flights, so 7, 8, 9, and then 10, and then probably 11 too, they're applying to Block 3 as it rolls down the proverbial assembly line. If you really want my honest opinion, this is inconsequential. Do not think about Starship like the Apollo program. That is a huge logic fallacy in my opinion. Don't do that. It's not Apollo. It's not the shuttle program. It's not that. A failure in the shuttle program or a failure in Apollo would be catastrophic. Well, it was catastrophic with the shuttle program. Failure during Apollo would have been terrible. Starship fails? As long as nobody gets hurt. All right, send another one. Because once again, the stakeholder expectations between Apollo, the shuttle, Starship are very different. They're very different. Remember how I just said a second ago, the Starship program is designed for mass production, something no rocket has been able to achieve except missiles. Right? That is a human-rated transfer vehicle that can land on Mars, it can land on Earth, fully reusable. That is an extremely complicated set of circumstances, especially the mass production one. But because they're trying to mass produce starships, you get a lot of rapid prototyping. Stuff fails. Thomas Edison tried 1,000 times to make a light bulb work, and then he finally got it to work. And I'm pretty sure we still use incandescent light bulbs 150 years on. Right? Think about it like that. And these failures are nothing. That's inconsequential. It's not a big deal. Oh, nice, Hellfish. There you go. Yeah, there you go, Event Dudes. That's what's going on, man. Current Starship missions are basically sounding rockets for the program. I mean, if you want to say that, Andrew, that's a little bit of a stretch, but yeah, I'd say that would be fair in the context of this conversation. Yeah, sure. If you want to look at it like that, yeah, absolutely. I wouldn't go around saying that though. People will get confused. But yeah, rapid prototyping, man. That's why you keep everybody's looking at Starship failures like, oh my God, we're so cooked. No, the more SpaceX blows up stuff, the more they're cooking, and it's cook or be cooked. All right, SpaceX cooking, man. They're cooking. They ain't getting cooked at all. Like they're doing the opposite of that. I know it seems like failure after failure is no good, but we're not used to this type of prototyping with rockets, man. That'd be great, Chris. Yeah, maybe you should do that. Figure it out. Aren't they slowed down by regulation? I don't think that's a thing. And I don't think that's been a thing for the last 8 months. And I don't think that'll be a thing for another at least 3.5 years, if you catch my drift. You picking up what I'm laying down, dude? I don't think your brother's XJ Jeep is running right. Ah, that's loud. Yeah, it sounds like you might have a miss. Yeah, Okay, pro tip, if your car engine sounds like a wounded duck screaming, yeah, it's probably not healthy. We all heard the SpaceX doomsday sayers back when Falcon 9 was being developed. In 5 years, all the haters will find something new to say that proves SpaceX is going to fail. I know, did I? I've been here, dude. I've been a SpaceX fanboy since 2013. The Cassiope flight was the first Falcon launch I ever watched. Cassiope was the first Falcon 9 1.1. I was at the first Falcon 9 landing in December of 2015. I was at the first Falcon Heavy flight in early 2018. I've seen 2 starships. I've been following this for a long time. And people do shift the goalposts. It's really funny to watch, actually. Yeah, real funny to watch. People are, reusability doesn't make sense. Reusability doesn't make sense. They'll never land a boost. You'll never reuse it. The space shuttle proved that you couldn't reuse things. Okay. All right. Cracked exhaust manifold causing the computer to think it's running lean and throwing all the fuel at it. Ugh. You like ducks? I like ducks. I've been driving the same XJ for half my life with regular maintenance. Dude, I've only seen one person ever kill a 4.0 Jeep. False. And that was S-Master in chat. I don't know. But that guy's one of those guys that if he gets behind the wheel of a vehicle, it's probably going to break it. Other than him, I've seen 4.0s run off no oil. Heck, dude. You want to see something crazy? Check this out. Here, we have a flywheel from a 4-liter Jeep. You see that? That's not supposed to do that. This thing ran and drove with the flywheel. Like that. So, yeah, you're absolutely right. They are unkillable. Yeah, no, there's not many things that drive right with a cracked flex plate. Your 220K just drove from Oregon to Texas with fresh plugs and a head gasket and a full load. Not a hiccup. They're really good motors, man. Yeah, Matt, that's pretty much right. Didn't you say that you'd be playing MSC for after hours? Yeah. Let's do it. I don't see why it happened. Pretty sure it's enough material in that flywheel. Yeah. I love my 4.0, but hated how slow it was. Very scary to get on the highway. Mm-hmm. Okay, guys. That's going to do it for the Space and Gridfin review. Gridfin and Sidewinder fin review. Somebody linked up this executive order. I will keep this in the queue here. I'll read about this off stream. But yeah. I want to take that apart in my work truck and see what that stuff looks like. Probably terrible. It's a Chevy. All right. So, shall we? I'm going to jog the VOD. You guys know the drill. And I'll try to get the racing rig out. It might not fit in here, but all right. Give me 5 minutes. I'll be back in a second. Thank you very much for watching Space News, the Space and Gridfin and Sidewinder fin review. And there will be another one tomorrow. See you then.